Welcome to qnawire.
Several forces are acting on this system. On block number 2, we have its weight force acting on it. Then, its weight force presses down the ground and produces the normal force number 2, which is exerted on block number 2. Then, on top of block number 2, we have block number 1, which exerts a force W1 on block number 2, which further increases the normal force of block number 2, and then block number 2 exerts the force on block number 1, which is this normal M1. On top of that, we have a force that is trying to push block number 1 to the right, and then block number 1 will try to move with respect to block number 2. So a frictional force will appear between blocks 1 and 2 that will try to keep block number 1 in place. At the same time, from the point of view of block number 1, block number 2 will try to move to the left. So what happens is that block number 1 produces a frictional force, F1, that acts on block number 2, trying to push it ahead. On top of that, we also have a frictional force on the ground that tries to keep block number 2 from moving. So there is even a third frictional force that acts on block number 2. And then we have to consider a very similar situation, but not an identical situation. It's similar because it has almost all the same forces, but the force F isn't acting on the top block, but it's acting on this lower block, and this is F prime. Then we have to calculate what is the minimum value of F prime such that block number 1 will move with respect to block number 2. We will have to use Newton's second law a lot of times, so I will choose the following reference frame. A vertical axis that I'm calling Y that points upwards, and a horizontal axis that I'm calling X, which points to the right. Then let this be situation number 1 and this be situation number 2. We are interested in situation number 1, so let's begin by analyzing such situation. Then, using Newton's second law, under situation number 1 on block number 1, on the x direction results in the following. The net force acting on the x direction, block number 1, is equal to its mass, which I'm calling m because both blocks are identical, times the acceleration of block number 1. Then, notice that the net force on the x-axis that is acting on block number 1 is composed by a single force, which is the frictional force number 2. Then we have F2 being equals to the mass of block number 1 times its acceleration. Now we apply Newton's second law to block number 2, still on the x-axis. So it tells us that the net force acting on block number 2 in the x direction is equals to the mass of block number 2 times its acceleration. Notice that the net force that acts on block number 2 on the x-axis is composed by three forces. The frictional force that the upper block exerts on the lower block, trying to keep it in place. The frictional force exerted by the ground on block number 2, and the force F prime that is applied to the lower block. So it tells us that F prime minus frictional force 1 minus frictional force 3 is equals to the mass of block number 2 times its acceleration. Then we have to notice that on the limiting situation that the problem asks us, where the block just starts to slide, all the frictional forces are the maximum possible. So it's true that we can use the frictional forces as the kinetic frictional coefficient times the normal force. So back to the first situation, this one, we can write it as the kinetic frictional coefficient times the normal force M number 1, which is the normal force acting on block number 1. And this is equal to the mass of this block times its acceleration. Now notice that on the vertical axis there are two forces acting on block number 1. The normal force and the weight force. So as block number 1 is not moving in this axis, the only possibility is that the normal force is equals to the weight force. So we can write it as the kinetic frictional coefficient times the weight of block number 1, and this is m times a1. But we know that the weight force is given by the mass times the acceleration of gravity. So this is mu k times m times g, and this is m times a1. So we can simplify the masses and get a value for the acceleration number 1. a1 is mu k times g. Then keep this value. Now, going to the other equation and doing a similar thing, we get that f prime minus mu k times the contact force that the block number 1 is exerting on block number 2. And such contact force is equal to the weight of block number 1. So times W1 minus mu k times the frictional force number 3. The frictional force number 3 is given by the kinetic frictional coefficient times the normal force that the ground exerts on block number 2. And such force is equal to the weight of the block number 2. Then we have this, and it is equal to the mass times the acceleration of that block. Then we can again write the weights as masses times gravity to get mu k times m times g minus mu k times m times g. And this is equals to m times a2. And now, notice that we have lots of this mu k times g right here. We can write it as f prime minus a1 times m minus a1 times m. What I'm doing is substituting mu k times g by a1, as we have discovered from our last equation. And this is m times a2. Now, in the limiting situation, the problem asks us a1 is equals to a2. Let me call it a. So we have f prime minus 2 times m times a being equals to m times a. So finally, f prime is equals to 3 times m times a. Now, we know what is the value of f prime. It is 3 times the mass times the acceleration of the blocks. And then how can we discover the acceleration of the blocks? We have to return to the first situation, because in the first situation, all the frictions are also the maximum possible frictions. And in the first situation, analyzing the block number 1, we have that 2 forces are acting on the x-axis, so that the net force in the x direction is given by its mass times its acceleration. Then the net forces are F minus F2, and this is m times a. But in this situation, the blocks are not moving yet, so the acceleration is at 0. Then F is equal to the frictional force number 2. But we know that F is 47 newtons, because the problem told us. So with that, we discovered that the frictional force number 2 is equal to 47 newtons. And why is this important? Because on the first situation, in this situation, we discovered that the mass times the acceleration of the block number 1 is equal to the magnitude of the maximum frictional force F number 2. And the maximum frictional force F number 2 is equal to 47 newtons, as we had just discovered from the second situation. Therefore, F number 2 is equal to m times a from this equation, but F2 is equal to 47 from this equation up here. Then F prime is 3 times 47, which is equal to 141 newtons. So this is the necessary force that one should apply in the lower block in order to make the block number 1 start to slide on top of block number 2.